Okay, but the audio should be better now. So as I was saying, we have various constructs for handling control flow. An if statement is one example. We can nest if statements to have more complex conditional statements. We can use an if-else statement to have a more complex one, but oftentimes these get unnecessarily cluttered. So we can use a switch statement to be able to have a variety of values that a variable or an expression is evaluated against. And depending on which of those values that we have described equates to it, then we're able to do many different types or many different select from a variety of options on what statements should be executed. All right, then loops. Well, you should have heard by now that a good attribute to have as a programmer is laziness. You should try to write the most efficient code. And so if we're going to have the same statements executed time and again, rather than having them written down over and over, we'd like to make use of loops so that same code can be executed time and again until, or at least as long as we're within some conditions. So for this, we can use a while, a for, or a do while loop. You should be comfortable with those. Of course, they will come up as you go along. We will oftentimes rather use these types of statements. So an if statement, an else if, nested loops, or like a switch statement, nested if statements or switch statement, and these types of loops. We'll very rarely explicitly tell our compiler, or rather our machine is executing our code, to jump from a statement to another one. But sometimes you have to do that. And for that, we can use these two statements: return, which you should be comfortable with. It simply ends the execution of the current method and returns control to the calling method that called that method. If there's a value returned, then that value is also returned along with it. Break does something special for us. It breaks out of the innermost loop, so it breaks out of the loop we're in at that time, whereas a continue simply breaks out of the current iteration of that loop and continues with the next iteration of that loop. So those both can control the execution inside of a loop, one to break out the entire loop, and the other is simply break out of the current iteration and go on to the next without executing subsequent statements. All right, and arrays. So oftentimes we will be storing a lot of values of the same type. And instead of having a sequence of different variables, we can simply set up an array, which allows us to have a collection of elements of the same type. And Java does that for us. They're native type that we're able to use. And so it's very useful for us. The only restriction we could say is that they're of a fixed size. And though you have, I'm sure, used array lists, which you think of as growable arrays, in the back end, those still use fixed sized arrays. In fact, we do have a practical down the road where you will have to implement your own growable array. And we see that we do use fixed size arrays, but when we're near our capacity, so when our array is almost full, then we'll simply create a new array and get rid of the current one. And that capacity is that fixed size of our array that we can only put in so many elements because of fixed size. And if we try to access elements that are of a higher index than the size of our array, then we will get an error thrown, and that's called an out of bounds error. Right, so we should be comfortable with declaring arrays. You simply use square brackets after the type, and that creates an array instead of a single variable. In Java, arrays are objects, which means that when we pass one, or rather, if we equate one array to another, we try to assign the values within an array to another one, then we actually create not a new array, but a new reference to the same array. All right, so that's important to note. So if we actually want to copy the contents of an array and put it into a new array, so assign it to a new variable, then we should clone our current array rather than simply try and use an assignment statement. Then packages. All right, this again you should be comfortable with. If we are creating a program that's rather sophisticated or has a lot of source code, it's convenient for us to group our code into packages. You can think of it as a directory or a folder in a file system. It allows us to group related classes together and also helps us to avoid name conflicts. So names of our classes have to be unique. However, if we package our code, then they only have to be unique within that package. And so that allows us to avoid the issue of having classes with the same name. And it also makes them better maintainable code. You can use these packages, and as long as you understand how they work, then you're able to make use of those in other code. And if I go into that package and change my code, as long as it works the same, and it doesn't matter what the implementation is, people who are accessing that package can still make use of it. All right, so as long as our arguments and the types of return types that we expect are the same, we can make use of that code regardless of how it changes. Then nested classes. It's possible for us to actually define a class within another class. Though note that you won't be able to access that class outside of that class definition, outside of the outer class, but oftentimes we have classes that are closely related, so the work that they're doing are closely related to one another, and so it makes it easy for us to read that code to when we need to make changes to that code, do it all in one place, and so we'd like to have one class that is used solely by some other class defined within that particular class. All right, and so those are nested classes. We can also define what's called an anonymous class. So for anonymous class, you usually have an abstract type that you've defined or an interface, and then you want to make a once-off version of that class for use perhaps in a single array or in a single variable. You're able to actually have the class definition at the line where you declare that particular variable or array. And so that allows you to define a class for once-off use. You don't give it a name, you simply, after the new keyword, have your braces and have the class definition. The object's created, it's assigned to that variable, but it isn't named, so you can't create other ones. We have a question here, is it possible to define a subclass within a superclass? I think that would be difficult within it, right? Because it has to be understood for you to be able to declare a variable of its type or to have one that extends it. You could have them within the same file, but you couldn't have one nested within the other one. All right. That's a good question. Then, please explain anonymous class again. I'm still not understanding what it is. All right. So we understand that we can define an interface which describes the behavior of a particular type, but does not have the actual implementation of those methods, right? And so I'm able to create a type that actually implements that, and I can give that definition within my declaration statement. So let's say we describe some type that we call vehicle. So we have an interface iVehicle, and I want to then define a class that then extends that vehicle. So I want to define motorcycle. So perhaps vehicle has accelerate and decelerate. I want to then actually implement that, but I'm only going to ever use it once. I want to create a single object of this motorcycle type, and I'm going to store it in this variable that I declare. So I can declare of type. Granted, I can't instantiate something on interface type, but I can create a variable of that type. So I would say iVehicle, my motorcycle equals new. And now I want to actually create a new motorcycle. The motorcycle has not been defined, right? So instead, within that, after my new statement, I could actually open my parentheses, give my entire class definition, or my braces, give my entire class definition. When that statement is executed, an object of that type will be created and stored within that iVehicle variable. However, I didn't give it a name. I didn't actually give it its own definition outside of that class. I'm not able to create more instances of it. But if I simply wanted to create a once-off object of that, it's not exactly a subtype, but it's one that implements the other, then I can do that. What is the difference between nested classes and anonymous classes? All right. A nested class, I can actually create as many instances of that as I want within the outer class. However, the anonymous one, it's a once-off. By naming it and doing it, even though it's within that class, but by naming it, I'm able to create more than one instance of it, whereas the other, I'm not. And in fact, I can also create variables of that type because I've defined it and given it a name, whereas the other one, I'd have to use some type that is higher up in its hierarchy, so like an interface or an abstract type. All right, so hopefully that helps. Then design. I know we all like to spend all our time in implementation. However, let me actually get an idea of whether we've all heard this. Okay, give me 1 second. All right. So there's a question, I'll answer that. But in the meantime, I want you to answer this little poll. Have you heard the 40-20-40 rule? And certainly if you've done CompSci with Mr. Greaves, you will have heard it at some point. When you say outer class, which class is this? All right. So I create my file in Notepad, whatever it is, or in Eclipse. I put there at the top that this is, unless it's in a package, let's say public class X, and then I open my braces. Within that, not within a method, but just within that particular class, I can actually start again and define another type. I can say class whatever Y, and I put the definition of Y within braces. I now have a class Y that's defined within the class X. I can then make use of it within the code of class X, and I can do it as many times as I want because I've given it a name, but it'll only be used within that. So I'd usually do that when there are things that I want to do, and I want a particular type of object to do that work, but it's only associated with the work done by the outer class. I'll leave it outside of that. All right, good, I guess. The majority have not heard of it. Some of you have, which is good. And I see that someone has actually given us the answer: 40% planning, 20% coding, and 40% debugging. So yes, it's 40% design, 20% implementation or coding, and 40% testing. Do people actually adhere to this rule? Not always, and certainly not when you're in varsity, but you should. So that means that even in a practical, before you start putting hand to keyboard, you should actually design your code to decide exactly what it is you want to do. If we say that Java is OOP and that the work of our application is done by objects, we should actually design those objects before we even think of implementing them, so we know what data are they going to store, what actions, what methods are they going to have, and also what interaction do we need between them. Someone says 50% programming, 50% debugging. No, no, no. Yes, if you do, you can end up spending a long time debugging, but that's not great. Is pseudocode part of the design process? Yes, definitely. All right, I'm not even going to read out that last one. That is incorrect. But yes, pseudocode is a part of that. So design can take many, many forms. You will remember that in first year, your design meant designing your GUI, deciding on what methods you have. I believe you talked about actions and events, right? And then you'd write out some of the pseudocode of what those actions should be. Do you remember that? I hope so. So only then would you actually implement, and then you would test to make sure that it works. You would debug by putting in some debug statements to make sure that everything works correctly. So yes, pseudocode is usually, or it should be, a part of your design, but your high-level design is deciding what my objects should be. I would usually use some notation to do this. You use a simplified form of UML in first year, and I'm sure, in fact, I know for a fact, in second year, you learned a lot more about UML, and you had assessments where you had to show that you understood that. So we have a language for modeling what a class will do before we even implement it. And that's exactly what we do. Then and only then do we decide, well, we kind of know what our methods should be. Let's write out in rough what code should actually go in there. Do you start coding right away? No. Instead, you write pseudocode, which is something that looks like code but is not, right? So when we ask you for pseudocode in the test, you should not be writing Java code. Pseudocode can have structures like conditional statements, like loops, assignment statements, but usually we try to write code that is human readable and not code that needs to be compiled. So it's not really code, it's pseudocode. Right. I'm sure you've heard the word pseudo before. We have pseudosciences. We have pseudo-random numbers. We know that a machine can't generate random numbers, but we can generate numbers that look random but actually aren't. Then the coding part, that you're completely comfortable with, I'm sure. Documentation, well, it's unlikely that you're going to make code only for your use. So your code should actually have documentation so that others can understand it without having to jump into its implementation. If you have good documentation, I should be able to make use of your code without ever seeing it. Then readability and style. Well, if I need to actually go ahead and read your code, I should be able to understand it. It should follow a particular convention. I believe you'd be taught that you should first start in a class by naming your identifiers, then constants, and in fact, some do constants, then your variables, your instance variables. Then you will have your methods. We usually have our constructors first, and then followed by our methods. So that helps us to understand the flow of it. And by adding comments, that then explains even the inner workings of each particular method. And we can also add comments to say, these are our constants, these are our instance variables, this is our constructor. And then for our other methods, we can use Java doc style comments to say, well, these are the parameters that we expect, and this is the values, these are the values that we return. All right. So by putting in good comments and sticking to proper conventions, you're able to create code that is readable even to someone who is not involved. Someone already asked, what about JavaDoc? Yes, that is what we use for good commenting. So instead of just using our / and putting in text that's ignored by our compiler, we can use JavaDocs to add comments that will be automatically generated into documentation. We'll still use JavaDocs for documentation? Absolutely. All right, then the last two, testing and debugging, which kind of go together. Ideally, we want to test our program on a wide range of inputs to make sure that it works for the range of inputs that we expect. But you may have heard before that you can't disprove something by example, which means that I can take a million examples of inputs, put them into my system, and it works perfectly. That does not prove that my system is free of logical errors. I could easily find one more input that makes it crash. And so, although we can't test for every input, it simply is not feasible. We want to have a representative set of inputs, and that usually means testing at our boundaries. So if we have an array as an input, we're going to test what happens when the array is empty, what happens when it's full, what happens when it perhaps has nulls or zeros in it. We want to test some representative set of inputs to make sure that it will work as expected. Then debugging is usually part of our process when we're testing. We'll add statements within that. The simplest way is simply to add a print statement, so we're able to track what the values of certain variables are to see, is it working the way we expect this? Granted, that's a very simple way of doing it, so when you have a complex application, you'll rather use a debugging suite or debugging environment to do this. All your popular IDEs, NetBeans, Eclipse have this. They allow you to run your code, set up breakpoints, and at that point where the execution reaches that point, it'll pause and you're able to check what are the values of the variables at that point. Right, which is a much better way than simply having print statements because you have to go back and delete those print statements, which isn't great. All right, these are the reinforcement exercises. Go and have a look. I have added them as requested on Eve. Granted, I just scanned it and used Adobe's OCR, so it won't be perfect, but it should be legible, and you can go ahead and take a look at them there. Right. So it's not that I'm just going ahead and assuming that there are no questions. What I am assuming is that this is a rehashing of what you've done last year. But if there is an issue, just put a question in the chat there and I will address it. So object-oriented programming has certain goals, right? We're using this paradigm to try and achieve certain goals. And these are the three goals that we discuss: robustness, adaptability, and reusability. Robustness is sometimes referred to as the ability or the attribute of a program to fail um, gently or to fail in such a way that it won't cause everything to just explode, right? Elegantly, that's the word they like to use, to fail elegantly, which means that if there is an issue, if you get inputs you don't expect, if errors are thrown, then it should not cause your system to crash. Instead, you should be able to handle it in such a way that your user is able to continue to make use of the application, or if it's one that doesn't interface with the user, it's able to continue its operation. All right. Adaptability, will realize that the environment within which an application exists or runs changes over time. Your code should be able to change over time as well, to evolve to suit the environment within which it exists. Reusability, well, we want to be able to use the same code that we create over and over. That's part of being lazy. They want to make sure that once we've created this code, we've taken all this effort, we should be able to use it again or components of it when we want to create a new application. Right? Modularity is part of that. By breaking it down into these small parts, we're able to use them again when we need that type of work done again. And in fact, you've also talked about design patterns, I'm sure, at some length, and that's part of that idea, that by adhering to certain design principles, we're able to create code that will allow us to reuse that code time and again. Abstraction is one of those things, which is the idea of abstracting away the inner workings of our data structures in our case, to the point that we only think about the most fundamental parts of it. If we take that idea of distilling a complex system into its most fundamental parts and apply that to data structures, then that gives us abstract data types. So although you've made use of data types like arrays, like linked lists, like stacks and queues, we're going to abstract away the particular implementations that you have done before and speak about what are the most fundamental parts. Then we'll look at, well, what are the different ways that we can implement them in such a way that we still adhere to what we've agreed are the most fundamental parts. What we'll find is that there are many ways to implement these data types, but it's important that you understand them as ADTs so that regardless of the implementation that you have, you can work with it. All right. So that's something that's a major part of this module, understand these data types, and usually that means discussing how they've come about, what are the aspects of it that are most important, and then we'll look at different implementations. Then encapsulation, well, the idea of separating our work into objects that will do that work is that within those objects, we don't need to know what's going on. So the object should be a self-contained module, and whatever else is going on in there should not be revealed to any code outside of that. Yes, these objects will interact with one another, but the particular implementation should not matter. That actually gives rise to the idea of reusable code, because we can take this code regardless of how we change it or not, but as long as it behaves the same on the outside, we can use it in different places. We can re-implement it if we want to, and so forth. And then a hierarchical organization, well, by creating subclasses of classes, by creating classes that implement other classes or extend them, we are creating a hierarchy between those classes. That one class is of the other type. So if we have a class human, and we then define from that male and female that both extend human, both of them are of the type human. So we're creating this relationship between classes, and that creates a hierarchy, right? In Java, our topmost type is an object, and we have others that then extend from that and continue down, down, down. And so we get this hierarchical organization of our different reps and types within Java. Oh, one asks modularity. Well, we kind of already talked about that when we're talking about the reusability, that if we apply, as I said, the idea of encapsulation to these objects and do the work, then that means that they are completely separate from one another. And as long as we understand their behavior, we can use them in different places, we can re-implement them, right? They are very useful to us, a lot more so than if we had the single monolithic code. We can only use that for the purpose for which it has been designed, and redesigning it would be a huge effort. But by splitting it up into modules which are self-contained, then we're able to reuse them, we're able to re-implement them. Separation of concerns, exactly that. And design patterns, exactly what I had discussed earlier. You will have covered design patterns last year. It's the idea that we can, by creating templates for software solution, we can create software that's a lot more reusable and also understandable, right? What are some of the design patterns that you learned last year? Factory, yes. Observer, I'm sure visitor as well. Facade, right, visitor, there we go. All right, adapter as well, I'm sure. We will use adapter quite a bit in the module. We'll discuss it more when we get to that. But a lot of the others, we won't make explicit use of them. But in your own design, and certainly in your projects, it helps to think within those parameters or paradigm, because then you can understand, well, what parts of my project do what work, and how, and if I need to do similar work, what parts can I keep, what parts do I need to change? All right. So a design pattern consists of a name and a context, so a scenario within which we would use it. There are algorithmic ones and then also software engineering ones. And clearly you have used some of them. As I said, I know that you've done them before, but before we use them in any application, we'll discuss them to make sure we're on the same page. Then inheritance, well, talked about the fact that by having this relationship between classes, it creates this hierarchy. Well, that relationship is created by extending one type to create a new type. And when we do that, that new type, that subtype inherits the behavior and properties of the type that it extends. So it helps us to create this modular code by having a hierarchical structure. The class on which the other extends is called our base class or a superclass. And in fact, if we go higher and higher on our hierarchy, we call that an ancestor class. The one that is extending the other is called a subclass or a child class that extends the base class. And we can have that done over and over as well. So we can grow our hierarchy in different ways. Because Java has dynamic dispatch and binding, it means that it starts searching for the implementation of a particular method within our the current object, and then moves up the hierarchy to find it if it doesn't find it there. This allows us to do things like overriding methods and so forth. There's a question, why can't one inherit more than one class? Well, this is perhaps a philosophical one, but you may run into an issue where you have a circular relationship, which is not what you want, because then we have ambiguity in the definition of that type. All right, the diamond problem, there you go. All right, but actually we do have a workaround for that within Java. We're able to define interfaces, and a class is actually able to implement more than one interface. So it can be of different types, but because we don't want this ambiguity in terms of, well, which particular definition we're going to use from these different types, then we don't have that. All right, but it seems you have discussed that before, which is good. All right, so polymorphism is the idea that a thing can take many forms. In object-oriented design, we're talking about these objects that can take many forms. And that means that even though we have one class extending another, we don't have to accept simply the definitions that are given in that superclass, unless, of course, that method is defined as final, as we learned yesterday. We're able to override a method to create a new implementation. We're also able to overload a method that will be either within the same class or within subclasses, where we have a different number or order of arguments that allows us to create different methods with the same name that, based on the parameters, or rather the arguments that are passed to them, the parameters that are passed to them, they can use a different specific implementation. All right, but just note that that part only worries about our parameters, not about the return type. So if you have two implementations or two methods that have the same name, same number and type of parameters, but different return types, then that doesn't work for overloading. There is a bit of a discussion on this and a problem that gets worked through regarding numerical progressions. That is in the text. That's just a self-study. It's pages 63 to 67. Please go and have a look. Make sure you understand it. All right. If you don't, then you know there's an issue and you can bring it up. All right, then exceptions. I think it's 63 to 67, but yes, 62 probably introduces the concept and then continues from there. So the question was, what pages was it on? Then exceptions. So you guys began your careers of coding by learning either VB or C++. Those languages aren't as strict when it comes to the handling of exceptions. Java really is. And so when we have an exception that is created and thrown by a method, it has to be caught at some point. If we don't have a try-catch clause within our particular method, then that means that the class within which it exists can also throw that method, because can also throw that exception. It won't catch it within that class, which means, or that method, which means that any other method that calls that method will then have to deal with it. Granted, it can then pass the buck itself, but at some point, that exception has to be caught. So any exception that's thrown has to be caught at some point. Okay, we have a little example of this. If we have a class that here we have, let's see, our previous class was, it throws a new my exception, we have a problem. And so here we have a method watching rugby. Doesn't have a try-catch block within it, but it can throw an exception. And so any method that calls that can also then throw that exception. So here we have planning Saturday that calls watching rugby. Because watching rugby then line 1 throws a no beers exception or a no Biltong exception, those have to be dealt with either in the method that calls it, planning Saturday, or in some method that then calls that method. Because if it doesn't have the try-catch block and deal with it, then it can throw that exception as well. So you'll see in the definition of planning Saturday, we also have throws no beer exception. All right, so at some point when we call that method, in some method that calls it, we will have to have a try-catch block when we call planning Sunday. If it throws this exception, then we'll deal with that in some way. Note, because we're saying here we can catch E, which is a type exception, we can catch either the no beers one, or I think the other is no snacks, but we only do something if it's of type no beer exception, then we send a friend. For the other, we don't do anything, but we have caught it, right? Even though we don't do anything based on its type. Then we can also have a finally block. That part doesn't, or that part is executed regardless of whether an exception is thrown or not. But if we want, we can have that part of the construct as well. Okay, so it's optional, and it's executed regardless of whether exceptions are thrown or caught. And interfaces. So an interface is a special type of description of a type that does not actually have any implementation. It doesn't have any description of the data that that type will store, and it doesn't have any of the implementation of any of the methods. So it's even more abstract than the abstract class. It simply defines how any type that implements that interface should behave. So any type that implements it has to at least have the behavior, the methods that are declared within that interface. Right. So it has method declarations with no body and no data. The methods are always empty. And because of that, you can't actually create an object of this type. It may not be instantiated. And any class that implements this interface must then implement all the methods that are described within that interface. So what that looked like, here we have an interface sellable, note, no data, so no instance types are described. Instead, we simply have methods here, and you'll see it's simply the signature followed by a semicolon. And so we don't have any implementation of those methods. If we have a class, for example, here product, which implements sellable, it has to at the least have implementations for those three methods. It can certainly have more than that, and it can have its own instance variables, but it has to at least have those three methods. And that helps us to get around that idea or that issue that we may think we have of Java not allowing us to inherit from more than one class, that we can describe behavior or two different types by their behavior by creating two interfaces, and create then a class that implements more than one type. So here we have motor car, which extends land vehicle. So it inherits whatever properties and methods are within land vehicle, but it implements iSellable and iPurchasable. So it has to at least implement the methods that are described within those two interfaces. And that allows us to actually create a new type that is of more than one type. This motor car is a land vehicle. In a sense, it is a sellable item because it adheres to this interface, and is also purchasable. If I was to create a variable iSellable, I should be able to store an object of type motor car in there. Same with purchasable. So I have created something that does adhere to the descriptions of more than one type, but cannot inherit from more than one type, because then we will get that issue where there's an ambiguity as to which particular implementation of a specific method will be used. An abstract type is simply then a type that has an abstract method. So a method that has a signature but no implementation. If a class has an abstract method, then it is an abstract class, which means that we may not instantiate it because some of its methods, at least one, does not have an implementation. However, we can create subtypes of this, and those should have an implementation of that type. So I have an example here, abstract class number, which is a class within Java, and all our wrapper classes for our intrinsics, our primitive types, have types that are subtypes of this number class, even though number itself is an abstract class. All right, and this leads us to the idea of casting up. So this is a nice example of that. Note, I've commented out the original code there because that was deprecated in Java 9. So if you were to try this using Java 11, you would get an issue there, either a warning or an error that you can't use that convention anymore. We now use integer.value of to create a new object of type integer. But if I was to do this, if I was to create an object of type integer, store that in I, and then create a new object of type number, or rather a new variable of type number, and store my integer object now in that. I'm allowed to do this because an integer, big I, is actually also a number because it extends number, so it's a subtype of it. However, because number is abstract, I can't create an object of type number. So when I have that statement in line 3, that is an upcast. I am taking an object of a subtype, and I'm storing it as a type that is a superclass of that. So that would be casting up. We have a question. What if there's no abstract method, but the class is defined as abstract? Well, then it's not actually an abstract class, but you're asking what would happen in Java if I do that? Well, go and take a look. I'm sure it will allow you to do it. But it wouldn't really make sense for you to do that because now you're ensuring that when you try to create an object of that type, then you will get some warning or error thrown at you. I mean, would the class be truly abstract? No, it wouldn't, because it doesn't adhere to our definition. It doesn't have an abstract method. Right, and I'm sure if you're working in an environment like Eclipse and NetBeans, it would actually give you a warning there that you've declared as abstract but does not contain an abstract type. Then casting down, again, this will be our last slide. If we now have an object of type integer that is stored, again, upcast and stored in a variable of type number, I can then cast this down to its specific type, to an integer. But because this is a downcast, right? Because we're downcasting, this object that's stored in a variable type number could be an integer. It could be a double, right? It could be a number of types. And because of that, I have to explicitly cast it to an integer. And because it could be more or different to an integer, I could also get an error thrown here, because if it isn't actually an integer that's within that variable, then I can't convert it or cast it down to that integer type. All right, there are a couple more slides discussing that, and some questions that you can take a look at in the last couple of slides. But I will finish those up tomorrow. There's only about 6 slides left, and we'll have plenty of time to look at our prac for the day. What was the promised hint about the prac? Okay, I have some bad news about the prac. I was writing the memo for it, and it was just too easy. So it won't just be arrays. We'll have some mathematical operations using those arrays, right? Because if we were just to ask you things like finding mins and maxes, even though you know that, it really wouldn't be much effort. No one would actually take the effort to do it themselves. We'll probably get a couple of copies there, and it's simply too easy. So it won't be something too hard. We'll just be doing some operations between them that I hadn't initially put in there. All right. Okay. And the hint that could help you is that you will be required to do file input and output. So go and look at the very least input. So go and look at your notes from last year for that. All right. Thank you very much. The recording will stop there. If you have any questions and you don't have to run up to a class, you can ask those in the chat and I'll answer them.